So, in the book, we talk about force diagrams. And let's analyze action and reaction. Force diagrams shows the forces that are balanced and unbalanced acting on a car and a wall as the car pushes on the wall. We're going to label these two forces that are shown and then draw and label vectors to indicate forces in this image. Scary person going by on a motorcycle. Okay. Hope they stay safe. Okay. So if we go to the ebook, we're going to think of this paragraph. And maybe I can zoom in here so you can get a better look. Okay, cool. In the diagram of a car pushing on a wall, the weight and normal force acting on the car are equal and opposite or balanced, like the weight and the normal force on the wall. So I can say that the weight of the normal force, let's draw. The normal force is the ground pushing up on the car. And force of the normal. And the force of the force the car exerts on the surface, force of gravity are equal. Okay, that's all well and good. So now, before impact, these are the only significant forces acting on either object. Okay, so there's also on the wall, there is the normal force of the ground against the wall. And the pull of gravity acting on the wall. Sorry for my G, my pen is just like pressure sensitive, and sometimes it doesn't write. Okay, now when the car hits the wall, the car pushes forward on the wall, and the wall pushes backward on the car, and they're equal and opposite, but act on different objects. So we can label this force as the force of the car pushing on the wall, and we can label this force as the force of the wall pushing on the car. The wall also has these internal forces of the bricks that prevent it from collapsing, which generates this force. Just like when you try to crumple a box and the interior materials of the box act against your hand to create strength for the box. So let's select the best terms in parentheses to complete this statement. For every action, there's an equal and doubled or opposite reaction. Forces in the universe occur in pairs. Ooh, duality of nature. I love that. Because each force in the pair acts on a different mass or acceleration. Okay, let's think. Each force acts on a different mass or acts on a different acceleration. The pair of forces can result in a net force on each object, such as when two pool balls recoil off of each other. Equal and opposite forces acting on the same object result in a doubled net force or a zero net force, and are also or not action-reaction pairs. Are equal forces action-reaction pairs? Are they doubled, or do they have a zero net force? So, with your partner or whomever, maybe you're watching this Edpuzzle with a buddy. Maybe you're not. What are some action and reaction force pairs you have observed today, since you woke up in the morning? When I draw on my pen with different strengths, oh, it doesn't do that. Oh, it kind of does it. Oh, there it did it. Less force made a thinner line. So my pen is generating a force on my pen pad, and the pen pad is generating a force on my pen. That's one. Compare your list with other groups. Well, let's go. Hi, Pixie. Y'all want to see Pixie Dust? There's Pixie Dust. Ooh, love you. Love you, Pixie. So, when we analyze action-reaction pairs, we can use a mathematical model. The first law of Newton's laws is that an object will remain at rest or in uniform straight line motion unless acted on by an external force. Okay, the golf ball will stay sitting on the tee forever. Okay. The second law, an object acted on by a net external force will accelerate in the direction of that force according to the formula acceleration equals the force of gravity divided by the mass. So, although the golfer hit the ball very hard, it's going in this straight direction. Eventually, the force of gravity will overcome and start pulling it downwards in the direction of that force. And the third law, for every force, there is an equal and opposite reaction force. Okay, what does this all mean? So, according to Newton's first law, because the golf ball did not remain at rest, nor go in a straight line. Oh, I know my golf shots never go in a straight line. I wish Newton could help me, give me a golf lesson someday. Ask my dad, he knows what I'm talking about. An external force acted on it. What net external force acted on the golf ball? I know, like, when I swing, my swing is not perfect. It's all kinds of sideways, which makes my ball go this way. Even though I sent it in my mind, I pictured it going that way. But maybe my club face is also not perpendicular to the direction I wanted it to go. My club face is actually all sideways, which means the ball went that way. There's all kinds of stuff with golf. It's an insane madness. I hate it. I hate it. I hate it. I hate golf so much. Okay. But I also love it, which is why I love to golf. Sorry. I'm just venting because of this last golf day I had with my dad. Okay. So, what external forces are acting on the golf ball? Very simple question. What are the external forces? Well, maybe there's gravity. Maybe there's wind direction. Oh. Going this way or that way. 20, 30 miles per hour, 5 miles per hour. Maybe the golf ball itself is spinning because I messed up my swing so much, and the spin is generating air resistance and and the air is causing the ball to go sideways and back into the bunker. Maybe this guy's glaring stare, it has like a Star Wars type force, and it's like impacting the ball through a metaphysical phenomenon that we cannot explain with science. That's what I think happens all the time. It's metaphysical. Because sometimes I don't even think and I hit a good golf shot. Sorry, I had to vent about golf during the video. My bad. Okay, now that you are familiar with force pairs, what are the force pairs acting on the ant? If it fell from 20 meters, why is that different than a coconut falling from 20 meters? Can you say a claim? Can you support it with evidence? Can you use Newton's first laws? Can you use Newton's third law, that equal and opposite reactions happen? If I hit the ground hard, the ground hits me hard. You ever try that? Try winning a fight with the sidewalk. The sidewalk's usually going to win. Okay, have fun, and I'll make this. This is going to be an assignment and your next quiz.